As we gaze upon the moon, it's easy to forget that this familiar celestial body, our closest neighbor in the vast expanse of space, holds secrets that could redefine our understanding of the cosmos. The moon has been a source of fascination for millennia, inspiring myths, guiding explorers, and igniting the imagination of generations. But in recent years, thanks to advances in technology and a renewed interest in space exploration, we've begun to unlock some of the moon's most profound mysteries. And what we've discovered is nothing short of extraordinary. Dr. Michio Kaku, a physicist renowned for his ability to make complex scientific concepts accessible to the public, has brought new attention to the moon with his thought-provoking insights. According to Dr. Kaku, the moon is far more than a simple, lifeless rock orbiting Earth. It's a key to understanding not just our own planet, but the entire solar system, and perhaps even the broader universe. The moon, he argues, is a cosmic archive, preserving evidence of the early solar system's formation, the history of Earth's geological activity, and even the potential for life beyond our planet. One of the most groundbreaking discoveries in recent years is the presence of water on the moon. For decades, scientists believed the moon was an arid, barren world. But thanks to a series of missions, including those conducted by NASA and China's space agency, we've learned that water is more abundant than we ever imagined. In 2009, NASA's L-Cross mission confirmed the existence of water ice in the permanently shadowed craters at the moon's poles. This was a monumental discovery, but it was just the beginning. The discovery of water on the moon took a dramatic turn with China's Chang'e 5 mission. This robotic spacecraft, which successfully returned lunar samples to Earth in 2020, revealed that water is not confined to the moon's shadowed regions. Instead, tiny amounts of water are present across much of the lunar surface, locked within glass beads formed by ancient volcanic activity. This discovery has profound implications for future lunar exploration. It suggests that water could be extracted from the lunar soil, providing a crucial resource for sustaining human life on the moon and potentially supporting long-term space missions. The implications of finding water on the moon go beyond simply quenching the thirst of future astronauts. Water can be split into hydrogen and oxygen, key components of rocket fuel. This means that the moon could serve as a refueling station for spacecraft on their way to Mars and beyond. Instead of launching all the necessary fuel from Earth, future missions could potentially produce it on the moon, drastically reducing the cost and complexity of deep space exploration. The discovery of water on the moon thus represents a pivotal moment in our journey to become an interplanetary species. But water is not the only resource that the moon offers. The Chang'e 5 mission also brought back samples containing a new mineral named Chang'e Y, after the Chinese moon goddess. This mineral is particularly exciting because it contains helium-3, a rare isotope that has the potential to revolutionize energy production on Earth. Helium-3 is a key ingredient for nuclear fusion, a process that could provide a virtually limitless source of clean energy. Unlike the nuclear reactors we use today, which rely on fission and produce long-lived radioactive waste, fusion reactors powered by helium-3 would be far safer and cleaner. The moon's vast reserves of helium-3 could thus become a crucial resource in our quest for sustainable energy. This discovery has sparked a new kind of space race, not just for exploration, but for the economic potential that the moon represents. Countries like China, Russia, and the United States are not just competing to plant flags on the lunar surface. They are competing for access to the moon's valuable resources. Private companies, too, are entering the fray, with visionary entrepreneurs like Elon Musk and Jeff Bezos leading the charge. Their companies, SpaceX and Blue Origin, are developing the technology to transport humans and cargo to the moon and beyond, with the ultimate goal of establishing a permanent human presence in space. Jeff Bezos, on the other hand, has a different vision. He sees the moon not just as a stepping stone to Mars, but as a place where industry could be relocated, preserving Earth as a natural reserve. In Bezos's vision, heavy industry would move off-planet, powered by solar energy harvested in space. The moon's resources, including its abundant metals and minerals, could be mined and processed in situ, reducing the need to extract and pollute Earth's environment. In this way, the moon could play a crucial role in ensuring the long-term sustainability of human civilization. The strategic importance of the moon has not been lost on governments either. The creation of the U.S. Space Force in 2019 was a clear signal that space, including the moon, is now seen as a potential arena for military conflict. The Space Force's mandate includes protecting the satellites that are critical to modern life, enabling everything from global communications to navigation and weather forecasting. But as other nations develop their space capabilities, including anti-satellite weapons and hypersonic missiles, the potential for conflict in space is growing. The moon, with its commanding view of Earth and its potential as a base for further space operations, could become a key strategic asset. But even as we contemplate the geopolitical and economic implications of lunar exploration, there is another aspect that is perhaps even more profound: the scientific discoveries that await us on the moon. The moon's surface is a time capsule, preserving a record of the solar system's history that is not available anywhere else. The rocks and dust on the moon's surface contain clues to the violent early days of the solar system, when planets were still forming and colliding with each other. By studying these ancient materials, scientists can learn about the processes that shape not just the moon, but also Earth and the other planets. One of the most intriguing regions on the moon is the South Pole Aitken Basin, a massive impact crater on the far side of the moon. This crater, one of the largest in the solar system, is a window into the moon's interior. Scientists believe that the impact that created this basin was so powerful that it punched through the moon's crust, exposing the mantle below. By studying the materials in this basin, we can learn about the moon's internal structure and the processes that have shaped it over billions of years. In 2024, NASA plans to send a mission called Artemis III to the lunar South Pole, where it will land the first woman and the next man on the moon. This mission is part of a broader effort to establish a sustainable human presence on the moon by the end of the decade. The Artemis program is designed to build on the lessons learned from the Apollo missions, but with an eye toward the future. Instead of just planting a flag and collecting a few rocks, Artemis aims to create the infrastructure needed for long-term exploration and development. This includes building habitats, establishing a lunar outpost, and developing the technology to extract and use the moon's resources. One of the key goals of Artemis is to explore the lunar South Pole, where scientists believe there may be large deposits of water ice. This region, which is in permanent shadow, is one of the coldest places in the solar system, but it is also one of the most scientifically interesting because it could hold clues to the origins of water on the moon, and by extension, on Earth. By studying these ancient ice deposits, scientists hope to learn about the early solar system and the processes that brought water to our planet. In addition to water, the South Pole Aitken Basin may also contain valuable minerals and metals, including those that are rare on Earth. The moon's crust is rich in elements like titanium, aluminum, and silicon, which could be used in future construction projects. The moon's low gravity also makes it an ideal location for building large structures that would be impossible on Earth. For example, giant solar arrays could be built on the moon to capture sunlight and beam it back to Earth as clean energy. These arrays could provide a virtually limitless supply of power, reducing our reliance on fossil fuels and helping to mitigate climate change. As we continue to explore the moon, we are also beginning to consider its role in the broader context of space exploration. The moon could serve as a base for missions to Mars and beyond, providing a testing ground for new technologies and a launchpad for deeper space exploration. The experience gained from living and working on the moon will be invaluable as we prepare to send humans to Mars, where the challenges will be even greater. Looking further into the future, some scientists and visionaries are even contemplating the possibility of terraforming the moon. This would involve creating an artificial atmosphere and climate on the moon, making it habitable for humans. While this may sound like science fiction, the concept is based on real scientific principles. By releasing gases like carbon dioxide and water vapor into the moon's atmosphere, we could create a greenhouse effect that would warm the surface and make it more hospitable. Over time, plants could be introduced to produce oxygen and create a breathable atmosphere. While terraforming the moon is still a distant goal, it is a fascinating possibility that could one day become reality. As we stand on the brink of a new era of lunar exploration, it is clear that the moon holds the key to many of the challenges facing humanity. From energy and resources to scientific discovery and space exploration, The moon offers us the opportunity to solve some of the most pressing problems of our time. But it also poses new questions and challenges that we have yet to fully understand. What other secrets does the moon hold? What role will it play in our future? And how will our exploration of the moon shape our destiny as a species?